As part of its material characterization lab, Sintavia offers comprehensive mechanical testing capabilities using some of the most advanced equipment available. Mechanical testing provides validation and confirmation to additive and traditional manufacturing processes as they relate to forces applied in static or dynamic applications. A mechanical test can validate newly developed material and process technologies, as well as provide a method of controlling quality. Typical mechanical testing properties include elasticity, tensile strength, elongation, hardness, fracture toughness, impact resistance, creep, stress rupture, and the substantiation of fatigue limits. Sintavia conducts a variety of fatigue tests on site, measuring the ability of materials to withstand the application of repeated load cycles. The company is equipped to conduct component fatigue testing, fatigue crack growth rate, fatigue toughness testing, fracture toughness, and low cycle and high cycle fatigue testing. These tests can all be performed in high and low temperature chambers, simulating the real-world environment of each underlying part's end use. Sintavia also performs tensile testing on site and is able to measure both ultimate tensile strength and yield strength, or the point at which plastic deformation begins. As part of this process, Sintavia conducts elevated temperature tensile tests as a proven method of evaluating the behavior of materials under a combination of heat and tension. In addition to fatigue and tensile testing, Sintavia also performs creep testing on site, allowing the company to measure the tendency of a material after being subjected to high temperatures to change its form in relation to time. Creep is high-temperature progressive deformation at constant stress. Similar to data from fatigue and tensile tests, data from creep is used in evaluating materials for jet engines, boilers, gas turbines, ovens, and other applications that involve high temperatures under load. Finally, Sintavia performs Sharpie impact testing on site. This test is used to determine a material's toughness or impact strength in the presence of a flaw or notch under fast loading conditions. The Sharpie impact strength is a destructive test that involves striking notched specimens with a swinging weight or pendulum at a series of temperatures to show the relationship of ductile to brittle transition and measuring the amount of energy absorbed by the material during fracture.
By utilizing mechanical testing, Sintavia can provide its customers design and material properties based on the specifications to which the parts are being built to within the additive manufacturing process. This can include verification to material specifications and/or actual component testing. Mechanical testing provides substantiation that the parameters used within the additive manufacturing process meets the customer requirements. Many material specifications have not been established at this time within the additive industry. Every manufacturer will need to develop process specifications for the additive fabrication method. Mechanical testing is an important part of this process. For example, within critical industries, the strength properties of the materials must be proven on a statistical basis that the single low-pass structures can meet a 99% probability with a 95% confidence. Redundant low-pass structures need to meet a 90% probability with a 95% confidence. To prove the material and design requirements involves a large amount of testing, and Sintavia is committed to this process to bring the technology to the next level for our customers and the additive industry.